This is Adding and Subtracting Linear Expressions, Part 1. In Part 1, we are actually only going to be adding linear expressions. But what is a linear expression? A linear expression is an algebraic expression in which the exponent of the variable is 1. So let's look at some examples of linear expressions. You may not even realize that the variable in this expression has an exponent because it's not always written there. But if it's not written, it is a 1. It's called a ghost 1. Sometimes it's there, sometimes it's not, but we have to know even when we can't see it, it still exists. So that 1 still belongs there. So negative 4x, or negative 4x to the first power, is a linear expression because this variable only has a power of 1. 3x plus 5 is also a linear expression because this variable x would only be raised to the first power. Even though it's not written there, we can imagine that's the first power. There's only one x there. So negative 7x plus x is also a linear expression because both variables x are only raised to the first power. So what's not a linear expression? So here are some non-linear expressions. We've got negative 4x to the 5th power. Because this x is raised to the 5th power, this is automatically not a linear expression. Or 3x squared plus 5. Because this x is raised to the 2nd power, it's not a linear expression. This is also a non-linear expression, negative 7x to the 3rd power plus x. Because this x is being cubed, this is a non-linear expression. Even though we do have a variable that is still raised to the first power, this variable is not. So this is automatically a non-linear expression. So let's look at a couple of examples together. So we're going to add this linear expression here. We've got the quantity negative 8z plus 4 plus the quantity 8z minus 7. Now the first and most important thing to do when you're working with algebraic expressions is make sure that before you do any work, that this thing is written as an addition sentence. So I do have one thing I'm going to have to change here. This minus 7, I'm going to make it add negative 7, add the opposite. And the nice thing about having an addition expression is that when we add, the order doesn't matter. Okay? You can do 8 plus 4 and you get 12, or 4 plus 8 is 12. You can reverse the numbers in an addition sentence and it's not going to affect the final answer that you get. So I don't need these parentheses to tell me which pieces to add first. I can add whatever I want first. The order doesn't matter in adding. So negative 8z plus 4 plus 8z plus negative 7 can be written without parentheses. Now I can change anything around in here that I want, and I am going to change it. I'm going to make this negative 8z plus 8z plus 4 plus negative 7. Now I rearranged it because I wanted my like terms by each other. Okay? So I'm going to combine the things that are alike. So I had these two guys with the z variable and negative 8z and 8z. They're actually going to cancel each other out. They're opposites. I'm going to get 0. And 4 and negative 7, my two constants, can be combined, and they give me negative 3. 0 plus negative 3 gives me a final answer here of negative 3. So this algebraic expression could be simplified to negative 3. Let's look at another example. So I always have to make sure that I've changed everything to addition first. So I need to add the opposite right here, make this plus negative 2. Now I'm going to distribute. I've got this multiplication I have to take care of here. So I'm going to distribute my 2 to this first term inside of my parentheses. 2 times 7.5 gives me 15z plus 2 times 3 will give me 6. And then I'm going to add the 5z and the negative 2 from the other parentheses. Now that it's all addition, don't need those parentheses anymore. And I'm going to rearrange it. I'm going to put 15z and 5z at the front, my two terms with z, plus 6 plus negative 2. I can rearrange it any way I want as long as I keep all of the terms. I had 4 terms here. I still have 4 terms here. 15z and 5z is going to give me 20z. And 6 and negative 2 is going to give me 4. This is as simplified as I can get this expression. 20z plus 4. These two cannot be combined because they are not like terms. At this point, I would like you guys to pause the video and try these 2 problems on your own. When you have come up with an answer in your examples box, go ahead and play the video again and then actually see if you got the right answer. All right, let's solve these 2 equations. So the first thing I'm going to do with this guy is make sure that it is written as addition. So I'm going to change this to plus negative 5. So now I no longer need my parentheses. I've got negative 4y plus 3 plus 11y plus negative 5. And I'm going to rearrange this to make it negative 4y plus 11y plus 3 plus negative 5. Now my 2 terms with y can be combined. Negative 4y and 11y here gives me 7y. And 3 plus negative 5 gives me negative 2. So the last thing I'm going to do to simplify this problem before this is my final answer is combine this plus minus. And I'm going to rewrite it as 7y minus 2. All right, let's try this last one. So I'm going to change this to plus negative 6 to begin with. Now I've got some distributing to do here. Half times w is 1/2 w. Half times negative 6 gives me negative 3. Now I'm going to distribute my 1/4 here. 1/4 times w is 1/4 w. And 1/4 times 12 gives me 3. So I'm going to rearrange these guys so my w terms are here together out front. And then I'm going to do one extra step here since I have fractions. I'm going to rewrite these with common denominators. I'm going to change this to 2/4 w plus 1/4 w plus negative 3 plus 3. So I'll combine my w's, and 2/4 and 1/4 w gives me 3/4 w. And negative 3 and 3 actually gives me 0. And I can add these together. Anything added to 0 is just that term. So I end up with 3/4 w as my final answer.